So here's take 2 on the factoring video. Hopefully this one does not have the audio cut out halfway through the lesson. Factoring is a very important skill. There are like 80 bajillion ways you can factor. If you Google factoring, there are a million valid ways that teachers online will show you how to factor. The way that we factor at Missy High School is called swing and divide. Now, factoring is when we take a polynomial written in standard form, a quadratic polynomial, ax squared plus bx plus c, and we're going to write it as a product of its factors. Okay, this is going to become what's called factored form. When we finish, we should have 2 sets of parentheses in our final answer with variables and numbers and a plus or minus sign in there. Now this is a form of division. It is the most helpful form of division that we can do with polynomials. So we did learn how to add and subtract and multiply polynomials. Now we're going to learn how to divide, but we're going to call that division factoring. Okay, factoring is the way we mostly divide polynomials. Now we're going to use a method called swing and divide. If you notice right here, this little image right there is going to be how we set up all of our swing and divide factoring problems. It is on your formula chart, so it is something that you can reference on the back of the formula chart in class. So one full example here of swing and divide factoring, the very first thing we're going to want to do is identify what A, B, and C are. Well, they're in alphabetical order in standard form, so A is next to the x squared, B is next to the x, and C is by itself. C stands for constant. So the A here is 3, the B here is 11, and the C is 6. We don't include the x squared or the x, we're just looking for the coefficient there. And we set up our swing and divide factoring. Now again, A times C goes in the top of your x puzzle. So in this case, A times C is 18. B goes in the bottom, that's 11. And then underneath the division bars is A. So in this case, it'll be 3. Now we want to solve the swing and divide factoring just by solving this x puzzle. That's our next step. Okay, we want to find numbers that will multiply to 18 while adding to 11. So I'd come to the side if I need this, and I make a list of the numbers that will multiply to 18. That's 1 times 18, 2 times 9, and 3 times 6. Now only one of those rows can add up to 11. Hopefully you notice that 2 times 9 will add up to 11. So we're going to put 2 and 9 as the numerators in the side of the x puzzle. This is how you've been solving x puzzles for forever. But when we're factoring, we're going to take it one step further. And if we can reduce each side, we're going to. 2 divided by 3 comes out to 0.6 repeated, so we're going to leave that as 2/3 because fractions are your friend. And 9 divided by 3, well, that's just 3, or 3 over 1. Okay? From there, we're going to write them as linear factors, which means we're going to start writing it in factored form. We're going to take exactly what was in our x puzzle when we reduced it, we're going to write it down into the linear factors. The first one would be x and a positive 2/3, so we put x plus 2/3. The second would be x plus 3 because we had a positive 3 as part of my x puzzle. Now, this little note down here is important. It says if we still have a fraction, which we do in our first factor, in this factored form, we swing the denominator forward. So we're going to take this denominator of 3 and we're going to swing it forward. That means it goes and sits in front of the x itself. I don't have to do that in the second factored form because the denominator is 1 or is disappeared. So the factored form of this would be 3x plus 2 times x plus 3. You have successfully factored or divided that polynomial. It now looks like a multiplication problem because multiplication and division are opposites. They're inverse operations. Okay, a lot of people started doing this, I've noticed, don't skip this step. When you write down the version with the fraction in it, I know you can swing it forward in your head, but don't skip that step. That's going to become important here very soon. Okay, our goal is to write all of these polynomials in factored form today. Let's do another example. Okay, it says to factor the polynomials. Factor is your key word here. Factor means we're going to write it as a product of its factors or we're going to get it into factored form. Again, the way that we do that is the swing and divide method. We're going to set up our x puzzle. A times C goes in the top, B goes in the bottom, and A goes underneath. Now, where did I get the number 1 from? Hopefully you're asking that question. There's an invisible number 1 in front of the x squared because if there's a coefficient of 1, mathematicians are lazy and we don't write it down. Now that we've set up our x puzzle, we solve it. We're looking for factors of 6 that will add up to 7. Factors of 6 are 1 times 6 and 2 times 3, and the only way to make 7 out of 1 times 6 and 2 times 3 is to add 1 plus 6. We reduce each side of this fraction, and then we write it in factored form. This is x and a positive 1. That doesn't look like an arrow. Let me try that again. And then x and a positive 6. And since I am done and I have nothing to swing forward, that's factored form. I successfully factored that polynomial. Y'all give number 2 a try. Pause the video right now. Now hopefully you gave it a shot. A times c goes in the top. Again, there's an invisible 1 right here, so 1 times 8 is 8. And b goes in the bottom, b for bottom. And there's an invisible 1 underneath the denominators here. Now the numbers that will multiply to 8 and add to 9, let's see, 8 is 1 times 8 and 2 times 4. Now the only way to make 9 out of that is 1 and 8. I reduce each side, and then I write it in factored form. X plus 1, x plus 8. Again, I got those numbers exactly out of the X puzzle once I reduced the fractions on each side. So those are really easy because the leading coefficient, or the a value, is 1, so we didn't really have to do any of the swinging part of swing and divide. But let's see some examples where maybe we do. We're going to skip to number 4. On number 4, we set up our X puzzle. Here's A, here's B, here's C. A times C goes in the top, B goes in the bottom. So 3 times 2 is 6, and then negative 7. Making sure that you take this sign with you. So b is a negative 7, so that goes in my denominator, or in the bottom of my X puzzle. Now my denominators this time are 3. They're not 1 because there's actually a number there for a. We make a list of the numbers that multiply to 6 that potentially will add to negative 7. We have 1 times 6, 2 times 3. Now if we look at our chart that's also on our formula chart to help us solve this X puzzle, we're looking for numbers where the top is positive and the bottom's negative. Now that means that both signs down here are going to be negative. And the only way to add numbers that are in this list for 6 and get negative 7 is if both 1 and 6 are negative. Then we play the reducing game. Negative 1 divided by 3 does not reduce to anything other than 1/3, and negative 6 divided by 3 reduces to negative 2. Pull those numbers down into factored form. Now this is a step I don't want you to start skipping yet. I do need to see the factored form with the fraction written there, with the exact signs that come out of your X puzzle, before you swing it. That's going to become important here in a little bit. Again, we're going to take that denominator and we're going to swing it forward. This is going to be 3x minus 1 and x minus 2. Now that is the factored form of this polynomial. That is the only thing, two things that I can multiply together to end up back with what we started with in number 4. We're just doing a form of division called multiplication. If you want to pause the video right now, I want you to try number 3. Number 3 still has an a value of 1, so it's back to being kind of easier, but it does have the funky signs. So pause the video right now and give it a shot. All right, hopefully you paused the video and you gave it a shot. Thank you for following instructions. We have A, B, and C. A this time is an invisible 1, so 1 times 12 is 12, and in the bottom is a negative 8. In my denominators will be 1 again because that's my a value. Now I'm looking for numbers that will multiply to 12 and add to negative 8. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. Again, looking at my formula chart, I know that if the top number is positive and the bottom number is negative, that both of my signs have to be negative. So the only way I can add this list of numbers together and make negative 8 is if I use negative 2 and negative 6. Okay, so I play the reducing game. Negative 2 divided by 1 is negative 2. Sorry. And negative 6 divided by 1 is equal to negative 6. We pull those numbers down. X minus 2, x minus 6. And that's my factored form because there's nothing left to swing. Now hopefully you're looking at number 5 and you're going, Miss Quigley, something's wrong with this one. You're absolutely right. There's something missing in this problem. What letter is missing? Is it A, B, or C? Hopefully you'll notice that this is an x squared and this is a constant, so that means that this is a and c. So I'm actually missing b. If I rewrote this problem where all of the letters were showing, it would be x squared plus no x's minus 25. Now I have an a b, and a c. B just happened to be 0, so we don't have to write it. Again, mathematicians are lazy. We set up our x puzzle. A times c goes in the top. 1 times negative 25 is negative 25. B for bottom. And underneath the division sign is a 1. That's A. The only thing that multiplies to negative 25 is 1 times 25 and 5 times 5. But if you look at our chart, if the top number is negative and the bottom number is either positive or negative, because 0 is neither of those things, then we know the signs are going to have to be opposite. Now, 1 plus negative 25 or negative 1 plus 25 does not give me 0, but 5 and negative 5 does. Play the reducing game. This is 5 and negative 5, and then we just drag those down into our factored forms. X and a positive 5, x and a negative 5. Nothing to swing, so I'm done. Hopefully you're also, now that I'm redoing this video and you've learned about the difference of two squares, hopefully you realize that this pattern I could have done with the trick, because this is actually x squared minus 5 squared. So it fits that pattern that we learned to take a shortcut. X first minus second, first plus second, which is exactly what we wrote down as the answer here. If you didn't recognize that, but you can do the X puzzle, your girl's happy. Last problem, pause the video, try number 6 by yourself. If we can do number 6, we have conquered part 1 of factoring. All right, hopefully you pause the video. Let's see, we have A, B, and C all showing this time, so we don't have to do any of the invisible numbers, but we fill this out. A times C is 12, 4 times 3, and B for bottom is 13. Now the number underneath the denominator this time is 4. We're looking for numbers that multiply to 12 and add to 13. And the factors of 12, again, are 1 times 12, 2 times 6, and 3 times 4. The only way to make 13 out of this list of numbers is to use 1 and 12. We play the reducing game. 1 divided by 4 doesn't reduce, so we're going to leave it as 1/4, and 12 divided by 4 becomes 3. Those are the exact numbers I'm going to use in the very first version of my factored form. X and a positive 1/4, x and a positive 3. But since I have a denominator, I take that denominator and I swing it forward before I say I'm done, and the actual factors of this polynomial, the two things I can multiply together in the correct format to get the original polynomial I started with, is 4x plus 1 and x plus 3. Again, taking just the denominator and swinging it forward in front of that term's x to finish it out. That is factoring.